Welcome to Nano Matters, the podcast that explores examples of nanotechnology. I'm Lisa Friedersdorf, Director of the National Nanotechnology Coordination Office. Here with me today is Alexis Carpenter, Chief Scientist at Triad Growth Partners and Axe Nano. So Alexis, can you tell us a little bit about what you're working on?
Yeah, we are really excited about this PFAS problem. And PFAS is per and polyfluoroalkyl substances. They are an emerging contaminants. This is a podcast, so you can't see me doing air quotes. They have been around for a very long time. They exist due to release into the environment from firefighting trainings, their broad use across all kinds of consumer products. And really the issue that we're facing right now is that they are very hard to get rid of and they're very hard to detect. And so we are trying to use technology and nanotechnology and specifically to address both of those problems. So we have a nano bimetallic zero valent iron composite that we are using to degrade these PFAS compounds in water. And then we also have a nano-enabled screening technology that we're developing to try and create a easy-to-use field deployable sensor that someone could, say, test their well water and see if there's PFAS in there.
So this PFAS, is this what they sometimes call forever chemicals?
Exactly. Yep. So really smart chemists were tasked with coming up with a chemical that you could put on a frying pan and burnt chicken wouldn't stick to it. And they did a really good job. These chemicals are very resistant to the normal methods of wastewater treatment. And so they do persist a long time in the environment.
So can you share how nanotechnology is playing a role with detecting these materials?
Sure. So one of the things that makes measuring these compounds so difficult is that they're often in very low concentrations. So they might be 1 part per trillion concentrations. Therefore, you need a technology that will have a very loud signal, even when there's only one compound present in a large body of water, something like that. So we can use nanoparticles, which have this special surface area to volume ratio and capture the unique reactivity and unique kind of enhanced signal that you can get from a nanomaterial to detect these very low concentrations in the environment.
And you mentioned field deployable. So how do you go about making these sensors and how do you use them in the field, or how do you work with other people in the field?
That is a great question. And the way that we do that is by having a great team of people that approach the problem in a lot of different ways. So we have technical people on staff that have knowledge in sensor design and development. We have material scientists on staff that know how to do that component. We also spend a lot of time talking to the people in the field. So talking to the environmental consultants that are currently in the field trying to measure these things and understanding, what are you using now? How is it working for you? What do you not like about it? We like to ask the question of, if you could have anything, what would it be? And kind of fitting all of those pieces together help us to create a thing that both works well and does what we want it to do technically, but also meets that need and gives them the data that they need to do their job well.
So how is nanotechnology used on the other side, which is the degradation part?
Yeah, so similarly, taking advantage of nano, as we mentioned before, the PFAS compounds are very resistant to any sort of degradation. And so if you wanted to degrade them, you typically have to use pretty intense oxidation or reduction reactions. And so we are using these composites that have nano components within them to harness this nano zero valent iron to degrade the PFAS components. So on a bulk scale, this type of iron would not do the degradation that's needed, but on the nanoscale, you can get degradation of the PFAS.
So if the PFAS is in water, are these composites with nanoparticles part of a filter system, or are they put into the ground, or how do you deploy this degradation technology?
Also a great question and something that we are trying to figure out right now. So we had some funding from the Air Force to determine the feasibility of using these in the lab. And we are hoping for some follow-on funding to answer exactly that question. So, for example, you might have PFAS that's trapped in groundwater. So it's below the ground surface. You could pump that water up above ground and then treat it in a big tank above ground. Or you could create what's called a permeable reactive barrier in the subsurface. So you kind of create a wall of material that's in the ground. So then as the groundwater flows through, you get that degradation. That's called in situ. There's pros and cons of both. Ex situ, pump and treat, where you treat it above ground, is a little bit easier to control, but it's going to be more expensive. In situ might be less expensive, but obviously harder to control. And that's really the gist of what we do at our company, is saying, okay, in real life scenarios, how are we going to implement this technology? What modifications do we need to do to the formulation to target it for that use? And then what's the best use form for this industry?
So looking a little more broadly about water treatment and purification, where do you see the most significant potential for nanotechnology to work in these areas in the future?
I think that our water and our wastewater infrastructure is a bit outdated, and it's expensive to redo the whole thing. But I think that there's a lot of opportunity to make really big improvements as we do that important infrastructure work for water and wastewater treatment. And I think in terms of nanotechnology, I think it's both treatment and detection. One of the difficult things is knowing when you need to have treatment. Your water sources are not always the same. And so a lot of times drinking water facilities are constantly monitoring their water to figure out what type of treatment do I need to turn on or off. Especially if that treatment is expensive, you can't run it all of the time. So it would be helpful to have quick turnaround on-site sensor that would tell you, okay, now your source water has this, you need to turn this treatment on. And you need that treatment to be really effective and quickly reacting. I think I'm certainly biased because those are the two areas that we're working in. But I think that those two areas, both treatment and knowing when you need to do the treatment, are big areas within water and wastewater that nano could help with.
Well, and you're already tackling one of the most challenging areas or most challenging contaminants that we're dealing with right now. Are there other types of contaminants that this approach might be effective at addressing?
It's funny, there's this term called emerging contaminants, but really it's just the contaminants that aren't regulated yet. And so they exist out there and they're kind of emerging into the forefront of what people are working on. So 1,4-dioxane is another really big area that needs a lot of work in terms of treatment. It is also very prevalent. It is less regulated, and it is also hard to degrade with traditional treatment systems. So I think 1,4-dioxane is important. I know microplastics is a big area of concern. I'm less familiar with that, but I think there's an opportunity to think about treatment technologies that will be broad spectrum, right? If we develop a thing right now that works great against PFAS, and then in a couple years, we have the next emerging contaminant and we have to develop a whole nother thing for that. Why not take the time now to kind of rethink how we do treatment and try and predict, what's going to be the next thing, and think about how can we use these nano-enabled things and integrate those into our systems now.
Similar to the universal flu vaccine that we talk about that can address any flu and not just the strain that we're focused on that particular year.
Right. It's a hard problem, but we always say if it was easy, somebody would have already done it, right? So we like to work on the hard things.
So when you look at environmental remediation and the technologies like the ones that you're developing either for sensors or for in situ remediation, how do you work with partners that are in the field?
It is so important to have partners because you don't know everything. And so we form great partnerships with people across the ecosystem. So we have manufacturing partners that help us think about what changes when you're making stuff at a 1 liter scale in the lab to 10,000 liters for manufacturing. We have partners that help us with, yellow iron in the field and how do we think about integrating the technologies that we're developing into kind of existing deployments to make that transition easier? And we have partners that help us think about the commercialization strategy. Even partners that are from totally different industries often will bring kind of new ideas or new ways of thinking, and that's always really helpful. So we have a great team, both in-house of our employees, but we have a really great outward team that helps us. I think we do well of forming a good team of people that ask different types of questions to try and get us farther down the road faster than if we were just trying to do it ourselves.
So, do you have any advice for students that might be interested in combining nanotechnology and environmental issues?
I was reflecting when I heard there was a high school teacher that shares these and just thinking, wow, I had so many questions when I was in high school and I have so many questions now. I think the difference is now I feel more confidence in asking those questions. So my biggest advice would be to ask your question. So often you hear someone talk about something and you have a question, but you're afraid to ask that because you think no one else has this question. Or if I ask this question, people are going to think I don't know what I'm talking about. More often than not, I guarantee you someone else has that question. And so my advice would be to ask as many questions as you can, because that really is how you learn. You won't look dumb. It's important and it's a skill. And I think it's a skill that we don't foster well enough.
That's great advice. So, Alexis, thanks so much for joining us today and telling us a little bit more about how nanotechnology can be used in environmental remediation. Do you have any closing thoughts that you'd like to share with our listeners?
I think the other big thing is, maybe this is for students or all listeners, but just the importance of network. I was reflecting on, Lisa, how you and I met through a mutual friend, and just it's been great to kind of keep in touch all along the way, and identifying those kind of overlapping circles of your network is always really fun. And it's nice to keep in touch and hear what people are working on, and identifying new areas to work together is always really fun.